Hello guys, this is Tafadzwa from StackDev and welcome to my YouTube course. In this tutorial, we are going to look at an interesting problem called a palindrome number. This is from LeetCode and it's tagged here as an easy problem. So this is going to be our first video to these LeetCode challenges. I'm going to make a couple of videos from here. So be sure to subscribe and like if you find this content useful. So a palindrome number, the problem says given a number, given an integer x, return true if it's a palindrome and false if otherwise. Okay. So a palindrome is basically a number that reads the same forward or backward. So for example, here we have an integer 121 and the output here is true because 121 reads as 121 from the left to right and also from right to left. So that's a palindrome. So it has to read the same. This one, it returns false because from left to right, it reads minus 1 to 1, but from right to left, it reads 1 to 1. There's no minus sign here. So this is not a valid palindrome. Same applies with 10 here. It's not a palindrome because it's 1, 0, but from right to left, it's 0, 1. Okay. And we're given some constraints. This number can be negative, as we have seen here, and then up to some big number here, some big integer. Then there's a follow-up challenge here which says, could you solve it without converting into an integer, without converting this integer to a string? Okay. So to properly explain this, we're going to attempt two solutions. One is going to be a brute force solution, which I feel like it's important to have brute force solutions in these algorithms before you attempt an optimized solution. So you should at least know how to solve it naively, which is what we are first going to do. And then the second part, we'll try to optimize that algorithm. So I'm simply going to switch to my board here. So we are given a number 1, 2, 1. Okay. So the first thing that we need to do is whenever you're dealing with most of these data structures and algorithms, you can't really work with integers here. You need for the most part to convert it to some sort of like a string. Okay. So let's assume that this is a string. The most naive solution here that I can think of is I will simply have this string, let's say as s, and then I will reverse it. Okay, so here I'll say string reverse. I'll reverse it naively with the function or some naive approach to 1 to 1 again. And then I'll compare my original string if it's equal to, the reverse string. If it's true, then if it's equal, then I'll return true. Otherwise, I'll return false. This is the naive solution. So this reverse part is going to be also the naive solution here, where I'm just going to use some, user-defined function in Java in this case, which is not, of course, recommended. But you could actually implement the reverse function in string manually. But in this case, for the sake of demonstrating, let's just quickly implement a brute force, let's say with Java in this case. So I'm going to jump back to our Chrome here. So the first thing, like what we have said, is we actually need to convert this number to a string. So I'm simply going to convert it to a string s, then I'll say string.value. So we use the value of function in Java here. Okay, so we now have a string here. This integer is now a string so that we can be able to apply our operations. So to use the reverse function in Java, I have to use, I can directly use it on a string. I think I can use a string builder for this. So I'm going to say, I'm going to initialize my class here, string builder, sp, equals to new, not new, string builder. Okay, so the string builder will give us access to the reverse function. That's the idea here. So I'm going to iterate through my string, my new string here with that, and I'll simply convert it to array. Okay, so you can implement it however you feel in any language. So here I'm using Java in this case. So if I'm doing this, I'm now iterating through the characters of this string. So the first character here will be 1, the second character will be 2, will be 3, and so forth. I'm going to append this in my string builder. So I'm going to append this character that I'm iterating. So what I now have a string inside my string builder class. The reason being, the string builder can give me access to a new variable that I'm going to define, let's say called reverse, my string builder variable dot reverse, and we'll convert it to a string. Okay, so this is part also of the naive solution. This reverse function, if you implement it manually, you can actually see that the runtime of this is actually O of n. Okay, then this variable, the string builder, the memory here in terms of the memory complexity is also O of n. Okay, of course this operation is one single for loop. We're appending to this. Of course this is also O of n. So here I'm just writing some time complexities so that we'll be able to explain, you know, the runtime and the space complexity of this. So once I have this, I'll now then apply my solution here. So my solution is going to be as simple as if my old string, okay, the one that I've converted, then I'll use the equals object function, sorry, in Java. Then if this is equal to the reversed, I'm simply going to return true. Otherwise, I will return false. It means it's not a palindrome. So let's try to run this. Okay, that's good, success. So it has passed all of our 3 test cases, this naive solution. And let's try to submit it and see if LeetCode will accept our solution. Yeah, so LeetCode has accepted our solution. We have passed all the 11,000 test cases, and our solution, we are only beating 9.45%, which is quite low. We are here on the graph where other people are somewhere here. So we'll try to optimize this. So here the space is off and the time complexity is also off, and let's try to analyze and see what they say. Oh, I need to pay for this. Okay, cool. So let's now try to understand how we can optimize this solution to run in O of n, okay, without necessarily introducing this space, okay, complexity. So which brings me to the next section, which I'm going to introduce a new technique, a technique called 2 pointers. So the 2 pointers technique, it's quite a simple technique, and it's very, very important, because you see that for most of the challenges that we'll be solving, especially on strings and arrays, we'll be using this 2 pointer technique. So what this 2 pointer technique says, so you are given a string, in this case 1 to 1, okay? You want to initialize 2 pointers, okay? A left pointer and a right pointer. And you want to initialize these pointers on the first index of the first element and the last index of the last element. The idea is for any algorithm to run linearly in O of n time, okay, is the time complexity, you only want to make a computation once on your array, okay? You don't want to do it more than 2 times, or, you know, you simply want to, in simple terms, you simply want to have a 1 for loop, which is going to run once, or 1 while loop, which is going to iterate once through this string or list or whatever, and then running in O of n times, okay? So the idea is you want to be able to use these pointers. In this case, we're comparing a palindrome. So one of the things is we'll simply compare if 1 is equal to 1, okay? If it's true, it means we now have a condition to move the left and right pointers. So in this case, if 1 equals to 1, I'm going to decrement this pointer and it's going to point to 2. Okay. And this also point, I'm also going to decrement it at the same time, and it's also going to point to 2 in this case. And whenever they meet, then we stop our algorithm. So for example, if we say we have another one like let's say 1 1 1 2, like 1 1 1, this is also a palindrome. So we do the same. We start here, left pointer, right pointer, we compare these two. If they're equal, we move them to the next. So L will be here in the next iteration, then R will be here because we are decrementing it here. Then we compare, are these number equal? 1 and 1, they're equal. So let's say here, to just make it interesting, let's say we had 3 here, we also have 3 here. So we do the same. So we are now on 3, this one is now on 3. We compare, if they're the same, we decrement, we move it until they meet. So when they meet, we then stop our solution. So if let's say we didn't find an answer, let's say here on 3 we had, let's say 4. If the left pointer on 3 compared to 4, it was not going to be equal, we then immediately exit. This won't be a valid palindrome. So this is the most basic example of the 2-pointer technique. We'll be introducing more examples in the following tutorials. So let's quickly go ahead and implement this idea. So I'm simply going to delete this for now. So let's now go ahead and initialize our left and right pointer. So int left, I'm going to start an index 0. Okay. Then the right pointer, I'm going to start at my index, at the last index. So here I'm simply going to get the length of the string and then -1. Okay. Then we can start our iteration. So in this case, we're going to use a while loop. The 2-pointer technique, you usually use the while loop. So these are basically patterns. If you do more examples, you realize that most of these problems, they are similar and the pattern you use is almost similar. So the idea is to grasp the concept, not the actual source code. If you grasp the concept, you'll be able to apply it anyway. So here we want to iterate as long as the left pointer is less than the right pointer. Okay, we want to perform some operations. So this is now the pseudocode. So inside here, we are simply going to check if the character, since this is a string, so I can say the character at left. Okay, if the character at my left is equal to the character of my pointer at the right index. Okay, if these two guys are equal, remember we said we then need to immediately move our 2 pointers. So we're going to move the left pointer +1, then we also move the right pointer. Okay, then we also move the right pointer here -1. So we are moving this to the left, the right pointer to the left pointer to the right. Okay, we want them to meet, converge at some point. Otherwise, if these two guys are not equal for any reason, it means this automatically is not a valid palindrome. So we then immediately exit out of this while loop and then return false. Otherwise, if this whole iteration is happy and they meet, then we simply return true. Okay, so that's it. That's the optimized algorithm. Let's try to run it. Okay, so it's a run it. So let's compare with our naive solution, which had 9.54% of time complexity, but surprisingly the memory was okay. So let's try to submit this guy. Let's see how it does this time. Oh well, yeah. So yeah, it kind of improved a little bit. But surprisingly, the memory is now lower, even though we didn't declare any memory here, which is quite interesting. So yeah, this was the solution. So in the following tutorials, we'll be looking at more concept of this. If you find it helpful, be sure to like and subscribe, and we'll be doing more interesting challenges. So maybe as a takeaway, if you can actually go ahead and try to solve this question without converting it to an integer. So let me know how you solve it in the comments. I will see you in the next one. Cheers.